Good day, ladies and gentlemen. Welcome back here with another IBP session of loci of points, in other words, loci of mechanisms. That is one of the second last chapters that we haven't done yet. The last one, of course, will be loci of helixes. This one over here, loci of mechanisms, it's often been asked in 2019, 2018, 2016, if I can remember correct, 12 and 13. Yeah, so it's not a question that you can just ignore in the process. It's often been asked, and it's a popular question. So between question paper number 2, question 2, it can be any of those 3 chapters, and you can also see that there's a combination of questions that might be asked. It's not only going to be only points of mechanisms. It can be something else as well. All right, let's quickly go to the PowerPoints. The loci of a point should always be work with the true length of the line itself. I will talk to you just now about that, and then also you have to work systematically from 1 to 2 to 3 to further onwards, and then also in case of a circle, you always divide the circle into 12 equal parts. Now, of course, most of the time, this is something to do with a circle in rotation. Right, now let's start with, say for instance, line AB is basically pivoting on point A, and it's falling towards C. Now, I think you can make your conclusion that is basically just straightforward there, an arc that will be drawn from there downwards. Right, so that is basically what is pointed out by mechanisms. I've got a line, and that line has got a certain marker, and that marker needs to be tracked on where it will be if it starts to rotate, if it starts to fall, or whatever the case might be. All right, so in other words, that is going to be straightforward, just an arc over there. Now, what if on line segment AB, I've got point D? In other words, I've got a ladder, and there's a ladder that's falling over towards C, and then the paint brush is standing against the wall, and then that paintbrush will make a mark on the wall as it starts to fall over towards C. Right, so in other words, the same principle will apply. I will divide it into certain degrees. That's my first stop, that's my second stop, and that's my third stop. So in other words, the profile I'm looking for, the path of D, in other words, will be more or less like that. All right, so now it can be like this. It can also be a slider. In other words, if I've got the ladder that is standing against the wall at B, standing from A, and it's sliding at A towards C, how will the profile look like? In other words, if I have to divide this area into 8 parts, and I have to divide the bottom part over there, that's going to be my first point, where if A moves outwards, at B, it will be at that point. At B2, it will be at that specific point. B3, it will be there. So the length of the ladder stays exactly the same the whole time as it's moving further downwards until I reach that point over there. It can also be the bottom part, A towards C, that can be divided into 8 parts. And then if I pull it towards C, how will B be starting to slide down wall BA downwards? All right, so that doesn't matter where you put this division, or here on the bottom or there on the top, it doesn't matter. All right, so now again I've got a paintbrush, and it's sliding, so therefore again I'm going to divide this into all the parts. So therefore that's the first point, second point, third point, fifth, 6th, 7th, and so it carries on. And then from there on, the last point will be over there. And if I draw the profile, that will be the profile of what it will look like if it's sliding towards C at the bottom of B. Now, of course, I can also have a crank, for instance. Now, a crank is just like an arm pivoting from a specific point. Now, the pivot point in this case is at P. The examiner will give me this information. Now, remember, the rotation of the crank is it's not a wheel, ladies and gentlemen. This should be drawn with a center line. This is very important. Otherwise, you're going to lose your marks by not drawing it in as a center line. So this crank profile should always be a center line. Now, this is rotating. It's pivoting on P. It's attached at A. Now, if this starts rotating, of course, this will slide the whole time on CD the whole time, and then R is the point I'm looking for. So therefore, this will be pushed forward. That length will stay the same. It's not going to become shorter all of a sudden. So that length can be measured from there up to this point, and I can measure the distance of A towards R on this new established line from from this point down towards where I find it now, and I can find R over there, and I can say for the first stop, R will be, let's say for instance, in that area. Then the second stop will be there, maybe, and the third stop and the fourth stop. But you can realize that if it's working with a circle, it's of good advice to take the circle and to divide the circle into 12 parts. And also try to number it in a sequence way, a logic way. In other words, if I'm working with A, start with A1, A2, A3, A4, and so it carries all the way over towards A12. This, of course, doesn't matter if you number it clockwise or anti-clockwise, because you will get certain stop points. That's the most important part. Right. Now, if I go to A1, it means that it's rotating from there towards this point. So therefore, that will be the first point I was looking for. So that length will be measured over there, and it will intersect at D. So that is the total length of AB. And I've got also R0. So R1 will be at that point now. That's measured from A towards R. Now from A1 towards R1, it's the same distance. Right. So that's what you will have over there. Now you can also do the same from 2, so you measure the distance of 2, and then from there strike an arc over there, and then you measure the distance for R, and try to do this all at once. Finish off with A2 and finish off with A3. Don't try to draw all the lines A towards B, and wherever you go, A1 towards B1, A2 towards B2, and then later on try to figure out which one is what line now to determine this length over there. So don't go that route in that regards. All right, so there we go with the R3. We're going to go R4. It starts pulling it backwards. You can see now R5, R6 goes all the way. It starts pulling backwards still. And now over there, it will start pushing it forwards. All right, so now it starts pushing it forward, and then until you get that point. So those are all the profile points. Once you've got all the profile points, you can draw in the profile of what the examiner is looking for. Now this is very entry level, very easy. Of course, yours might be attached to a lever or to a rod, or maybe going through a pivot point and so on. So that this brings us to the next option that we have. That was the first option, it's sliding. Second option, slider going through a ring. All right, so in other words, same principles that you will apply. Now they're saying to me that AB is attached, going through a eyeling there or a ring at that point over there. All right, this is the crank. In other words, this is the distance, the area it will rotate in. And I have to divide this into, of course, 12 parts. So there we go with the 12 parts over there. And then from there on, again, it doesn't matter clockwise or anti-clockwise in this case. So therefore, I have to now remember that every time it goes through that point. So that's the length I'm talking about. B is the profile I'm looking for. But now just remember, B can also be some distance shorter or shorter over here. It doesn't matter. So the point is I have to focus on B. So therefore, if I go to A, from A through the ring towards B, that's the length. So if I go to A1 through the ring, it will, wherever it ends, I have to measure the distance of AB and find the distance of AB and get point B at that point. All right, so let's quickly go through the motion. There we go. That's the distance of B. And like I said, B can also be shorter. It doesn't matter. In this case, it's on the end. Then I go to C, going through R, find the length. To A3 and go through the R and then find the length. And then A4, A5 to find B5, A6 to find B6, and so we're going to carry on with those true lengths the whole time being established. All right, and then from there on, that's 11, and that's number 11 over there, and that's number 12, back to number 12. So the profile I'm looking for is that profile. Don't rub out your lines, your construction lines, point number 1. Point number 2, also work systematically. Don't draw, you can see how close these lines are apart from each other. So work systematically by completing A completely towards B, and then A1 towards B1, A2 towards B2, and so you're going to carry on with all those lines. All right, so there we go with the second option, where you have to go through an eye of a ring or something like that. All right, then the third option over here is your connecting rods. In other words, you've got a rod connecting with that part. All right, so there we go. Again, this is showing to you the crank profiles. That must be center line, and this is also a center line because it shows you the arc of what this crank or this rod will be making at that point. It's attached towards R, so in other words, it can't move to the left and to the right. That is the total length. It can also be at B at a certain shorter distance, or maybe between A and R. It can also be going further onwards. It doesn't matter. The most important, A towards B will remain the same distance, and this distance is attached, so therefore it will either pull this rod closer or further away. Now I think you can make the consumption that if this is a rod, it's a steel rod and it's attached towards that point, it can only move and pivot from this point onwards. So therefore it will only be pulled inwards or pushed backwards towards that part. So it will make an arc because the distance will stay the same the whole time from C. So I can start by saying, draw the 12 parts in your crank parts on your at A, and then draw the arc in from where you're going to need this. You can see the rod won't move closer or further away. And then I will have, again, it doesn't matter clockwise or anti-clockwise. In that case, I will be able to say, all right, that is A1. It's attached to that point, so therefore it can't just, all the lines can't just go through there. It's been pulling towards closer or pushing away. So that distance is important. So I have to take the distance A towards R, and from A1 towards R, I have to find out where will it be at that stage if it's been pulled inwards. And then I take the line from A through that point onwards to find the distance of AB on this new line over here. Let's quickly show you. All right, so there we go. It's basically pushed a bit forwards. And then from there on, the distance is the same. AR is the same distance I'm using over here. It's now at that point. And at that point, it goes from there through that intersection point onwards. How far do I carry on with that line? Obviously, AB is a certain distance. So therefore, I have to stop at AB at that specific point. All right, let's go to 2. There we go with 2. I find my arc. It starts pulling it backwards on this arc, of course. So that's my intersection point. That's the distance, which is same as A and R. So that's been measured up there. It's extended for how long? For the distance of AB, and I find the distance of AB at that point. All right, so if I go to the distance of A towards R and go to A3, it will be pulled further backwards. There you can see that's the intersection point, so that's the real distance. Being extended, AB being measured from A3, I find B3 at that point. All right, by number 4, I think you can also see it's been pulled backwards, so therefore it's going to be at that intersection point. That's the true length. Being extended for how long? The distance of AB, and find B4 over there. At 5, we go there. There we go towards that point. At 6, still pulling it backwards, going through that point over there. At 7, still pulling it backwards. I think by number 8, it will start pushing it to the front again. Yes, there we go. Can you see now 8 is been pushing it forwards towards that point over there. By number 9, it will be pushed forward through that point onwards for the length of it. At 10, it will be pushed forwards from that point onwards to find the point at B10. At 11, it will be to that point, and then by 12, it will be back to 12. So therefore, there's the profile I was looking for, and that's what I need to determine by means of this. All right, so this is your third option, where it goes through an eyeling. No, sorry, where it goes through a crank or a rod that stays the same distance the whole time. Right, and then this one over here, this is linked cranks. In other words, I've got 2 cranks over here. I've got this one over here, which is pointing out to me point A, and this one over here, which is an eyeling. It goes through, it can sliding through that eye over there, or through that ring, but the length of A to R will stay the same. Now, in this case, it is important to see what is the rotation of these 2 points. All right, so this point at A is rotating in a certain direction, and that point is rotating in a certain direction. The examiner will tell you in which direction does this one rotate. This one, in fact, it goes into a clockwise direction. And this one over here, it started at B, now it goes into this, so it goes into an anti-clockwise direction. So that makes a huge difference. So direction is very important when it's 2 cranks, and this one goes through a ring, for instance. All right, so my first stop with this circle will be at this one if it goes clockwise. If it goes anti-clockwise, my first stop will be at that specific point. All right. Now the rod stays the same length. It doesn't become shorter or longer, but it can pivot through this point over here. Not pivot, it can basically slide through this point. So if I stop at this point, this will be getting closer to each other. So therefore, in that case, it will be pushing the rod further outwards towards that point. If I go to 2, which is my next point, and 2, which is my next point, I will get a straight line going through there. It's been sliding through this eye towards that point, and that's the length. Still the same length as what it was from the beginning. Right. At 3, it will go to 3. There we go with that part. At 4, it will go through to 4. At 5, it will go through towards 5. At 6, at 7, at 8, at 9, at 10, and from there on at 11, and then the last point is back to 12, and there's the profile I was looking for. All right, so now, again, this can be a larger crank to a smaller crank. It can be clockwise, both of them can be clockwise. One can be clockwise, and the other one can be anti-clockwise. So it's important to know that the direction is important with this part over here. Right, ladies and gentlemen, this gives us up to this point over here. What I'd like to explain to you in terms of the exam papers, like I said to you, it's often been asked, and it's often been asked in a combination of questions, like this one over here. This was asked with a square thread. This was asked in 2012. All right, so this is again given. All right, given the schematic diagram that you see over here with mechanism consisting of a crank. Now there's the crank, and you see the examiner is giving this as a centerline circle, not a solid circle. It's not a wheel AB, which is attached to a connecting rod AC. All right, so there we go. There's AC over there, and that is going to be sliding all the way up to the left and to the right. But for the starts, I have to take that as 70 millimeters. I have to take that as 78 millimeters, extend it for another 20 millimeters, and then this will rotate, and it's 35 millimeters in radius. All right, so that's what has been given to us, and then O has been given to you on the drawing sheet, which is this point over here. So you have to start working from O, from there further onwards. Motion as crank OB, that's the crank over there, is rotate in a clockwise direction. Again, it doesn't matter clockwise or anti-clockwise, but it's clockwise in this case. Point A moves along and fro, to and fro, in other words, towards and from D to D on that line over there. Right. Then instructions, draw to scale 1:1, and given a schematic diagram, and you have to redraw the mechanism. Now, ladies and gentlemen, again, if I go down to the mark sheet here on the bottom, it points out to you given is 4 marks out of 18 marks. So please, you're not going to pass on that. You have to make sure that this is basically the correct way. And then trace the locus generated by point C. Right, so the locus at point C of 1 complete revolution of the mechanism. So it's going to slide over there, but I'm looking for this point. I'm looking at the profile that it will make at C at this point over here, and show all the constructions. Don't rub out your construction lines afterwards. All right, so that is what the question was. Now this is the crank. There it slides. You can see it can also slide on the bottom upside down. So that's the sliding process that's pointed out to you there. And then it's been extended for 20, extended for 20, extended for 20, 20 outwards, outwards, outwards every time. But you have to know the principle that it's sliding on that point. It can't go somewhere else than that part over there. And that's what you will get once you're done with this part. All right, so again, curve quality and the constructions and the locus and so on. If you are, say for instance, with the start of line segment A going through B towards C, and you made the wrong dimension over there, the long distance, then, or the crank, for instance, is drawn too big, then of course the escalation of the mistake that you have done over here will be much further, much bigger over here, and you're not going to get your marks in terms of accuracy if it goes to that point. All right, so please make sure that you work very accurately, very accurate on all the drawings. This also again was a combination question asked in 2016. Now what they ask you over here is basically the mechanism. It's been given to you there. Don't start getting a fright because of the fact that it's so busy. Just see what is exactly it's been asked over here. All right, so it points out to the drawing of the mechanism. consisting of crank OA, there we go, and also connecting rod AB, there's a connecting rod AB. Swivel guide C, so it's swiveling at C, in other words, that's the I we're talking about. This is the one part of what I've explained to you just now, right? Then the second part of it, it has got a crank over here, and then this crank, or this rod that you see over here, also has to go through that specific point at F, the pin at F, all right, and the horizontal groove GH, so therefore there's a groove over there. So that will slide on the bottom over there. And then the position of point O on the drawing sheet. And then specifications, O, C, and groove GH are fixed. In other words, O is at the point you can't go without, so therefore you have to measure and you have to determine where exactly from O, how far, how high, how wide, and whatever the case might be. So those are all fixed. O is fixed, C is fixed, and this groove GH is also fixed, right? So that's going to be staying there. That's not going to move. This rod, however, will start moving, pushing inwards and outwards through the eye over there. It's connected at D. Connecting rod AD is joined to crank OA at A, and then the sliding rod DE, that one over there, is also pin joint. In other words, it's pivoting at that point. So as this is moving upwards and downwards and inwards and outwards as you go from there around the crank, this will move along all the way up there because it has got some sort of hinge over there that's making this thing to move over there. And then F, of course, is fixed to sliding rod DE. That's not an I. That is not something that has to go through there. This will start moving and rotating and inwards and outwards and upwards and downwards. But that point, that distance will always be the same at all times. So therefore, that's going to be at that distance that it's talking about. All right. Then they give you some dimensions over here to say to you DF is 40 millimeters apart from each other, and so it carries on with all the other dimensions. Right. The motion, the crank OA rotates clockwise. It could have been anti-clockwise as well. I've got no effect on that. But in this case, clockwise for the numbering. Direction, connecting rod AB freely slides through swivel guide C. So it's freely sliding through that point, pushing outwards and pulling inwards and so on. All right. Point E of sliding rod DE, that is point E of DE, on rod DE, reciprocates along groove GH. In other words, it goes all along with that line over there. It starts sliding inwards and outwards during the rotation. All right, draw to a scale of 1 to 1 on the given schematic drawing that you see over here. Trace the locus generated by point F to one complete rotation of the crank OA. All right, so they're looking for F. All of this is just to find what is F will do in the process if it starts rotating. And then again, show your construction lines. This is 20 marks. Now it takes up a lot of time in terms of doing this, so just be careful in terms of that. All right, so now this has been rotated. It goes through that point onwards. It doesn't matter if you draw it onwards, just as long as every time it goes through that point, wherever it goes, it doesn't matter because it has got nothing to do with the answer. That has to do with the answer. It has to go through there. And now, of course, D has been connected towards this rod over here, or at AB. And now it's been pushed forwards and pulled backwards and so on. So every time D has been changed position all the times, and it goes through F. So it's sliding on G, so therefore I have to find out where will F be at that stage. So if I measure the distance from D towards F, which is the distance from there to there, all the time, if it starts pushing inwards, where will it be then? If it starts pushing inwards, where will it be there? Where will it be at that point, at that point, at that point? And so it carries on the distance over there. I will get my increments, and every time it's sliding on that point, remember with the slider, we said from there I will chop an arc over there to see where exactly will it be ending off there. I can't just make it longer and shorter as I wish. So D will be placing there, so the distance of D towards E must be measured now from that point as an arc to say it will be at that point on the sliding, and then on that I will find the distance of DF at that point at this distance over there. Right, so that is basically what it points out to you every time it's pushing forward. Now going back to the slides, ladies and gentlemen, this is a combination of 2 or 3 of those slides, the different methods. I've got the eye over here and I've got the slider over here. So those are the 2 methods that's been combined in this case. All right, this was asked in 2016, like I said, and then over here, this question is the next question I want to point out to you. This was a question in 2018, again a combination question, and this is what was given to you. Again, you got the crank, again you got a rod sliding, that's your slider, that's the distance of the slider, and it goes through an eye, so therefore whatever happens with C moving inwards or outwards on this rotation, it will take CD and push it through this part or pull it backwards through this part over here as the eye. So it's pretty much the same as the previous example that I've showed you just now. The only difference is it's a bit lopsided, it's a bit upside down. The slider is not here on the bottom like the previous exercise, it's now at the top. So therefore we can take the slider on this part over here and see exactly where will B be. Remember, this is going to be an arc at that point. At that point it's going to be an arc. At that point it's going to be a... But on BC, there's a distance of AB, there's a distance of AC that I have to measure. So if I go to this point, where will AC be there at that? If I go to this point, going through the end point, where will AC be at that point, AC at this point, and so therefore I get the profile of this part. While it's profiling, while it goes up there, it goes through another question and saying to you, I want to have another area to be reckoned with. On the distance of C going through E the whole time at D, that distance, if I'm there and go through E, where will it be at this point? So CD needs to be measured at this new established distance over there. And then also the new established going through E, where will it be at that point? Where will it be at this point? Where will it, and start pushing it in, pulling it inwards. So again, it looks very busy, but systematically, you can work it out by saying, if this is a slider, this is the easy part. When I explain it, you said to yourself, most probably, this is easy because it's sliding and I just need to determine the true length of that. Yes, it is. Then I have to find where's C at that stage. So therefore, on each of those, I have to find out where will C be when it's at that specific point, still sliding on that point. Then from C, I have to go through E. So I can go from C, drawing all those lines, going through E, going through E, going through E for all of those 12 points that I've got there. And then I've got a distance to measure from C towards D. So I can go through this one, going through the center, where will D be? If I'm going through this point, through that, where will D be? And so it carries on. So therefore, this is the answer that you will get on the end. Again, very accurate, please. Accuracy is very important, because if you make a mistake on the dimensions or measuring over here, then obviously this will have a huge effect on this part over here, and definitely it will not look the same as what the examiner is looking for. Remember, he's going to make a transparency out of this. Take that piece of plastic and transparent, print it, this answer printed on that plastic transparent. You're going to place this, which is generated through a computer, onto your drawing. So yes, you have to measure absolutely 100% correct from each point if you do this. And please start with the crank distance. If the crank distance is wrong, this distance will be wrong. That profile over here will also be wrong in the process. All right, so that's what I want to point out to you here. Then the last possible example I want to point out to you is this one over here. Again, it looks very busy. It's pointing out to you, and it's a combination question again with the previous year. This was asked in 2019. Right, so in this case, it points out to you the direction. This direction goes clockwise, that direction also goes clockwise. And if it's 2 circles, direction is very important. So you have to bear in mind the direction itself. This has been given. So obviously there's the dimensions, and the dimensions going inwards. If you make a mistake over here, you're wasting time. Because if you make the mistake over here, all of that will differ to a great extent to your answer. You start at A, and you make sure that this dimension is perfectly radius of 50 millimeters. Make sure that the measurements from there going downwards to find this point over here apart from each other, 22 millimeters apart from each other, getting the distance from A towards that point, 22 inwards to find E. Take your radius of 30 millimeters, draw the arc over there, or the circle over there for the crank the rotation of the crank. Again, please have a look on the type of line that you will use over here and over there. Then make sure, put it on this on 60 degrees, find that point, set your compass on 85 and chop an arc at this point over here, or strike an arc over that point. And then from this point, 30 degrees to the side of it, strike an arc 100 millimeters away to find the intersection point at C. Now this is a whole process of going through just to get 7 marks out of 19 marks. All right, so this is the copying of it. It's close to 45%, 40% of the question. And now what they say over here, if this is pulling towards that point, that's the first stop that I will have. The second stop on 30 degrees, this third stop on 60 degrees, and so it carries on towards this point. And the same with that. If I take this point B and rotate it in a clockwise direction and find the first point, the second, the third, the fourth, the first point, and then I measure this and strike an arc, and I measure this distance and strike the arc from wherever it be, I will be able to rotate and to see where C is moving the whole time. All right, so over here, this is the rotation of C. It's been pulled forward or pushed backwards every time 100 millimeters from these points that you've determined at those ends over there. All right, so every time it was 100 millimeters been pushed or pulled forward. And then this one over here, according to the question paper, it was 85 millimeters from D towards C, wherever C will be. So every time I've struck an arc from that point, 85 millimeters to find the next points, and then over here my next point, which will be this one, 100 millimeters, strike an arc, and then this will be the second point, 85 millimeters, strike an arc. Where that intersection will be, that's going to be my next point. Then from there on, my third point, 100 towards there, strike an arc. My third point, 100 towards there, strike an arc over there. So again, numbering is important to see. You're working with number 3, working with number 3. The distance is important, so make sure that the distance is always 100% correct, and then of course you get your answer afterwards. So in fact, these are 2 rods attached to each other, and that has an effect on where exactly that will be at that specific stages as you move along with these curves. Ladies and gentlemen, yes, that is basically what I have for you in terms of mechanisms. You can also understand that mechanisms can be a quite difficult one, especially if the drawing gets busier with more cranks, with more pivot points, with more eye-lings, with 2 circles rotating in different directions. So make sure that you understand the principles. Always work with the true length and work systematically. If it's rotating, where's the first 30? And if there's a second circle it's rotating anti-clockwise, where's the first 30? And then find out where exactly the points will be, how it slides, how long it is, and all those type of things and so on. So the principles are on the slides, where if it's a slider, the distance will stay the same, so you'll just push it inwards and outwards as it moves on. And if the principle is going through an eye, it means it goes through that point onwards for a specific distance, and you have to measure the distance. I really appreciate your attendance, really appreciate the fact that you have listened right through to the end, and I hope that this helped you a lot. Thanks a lot. I really have a nice day further onwards.